This is an IIPMT question in electric potential and capacitance depending on electrostatic potential energy. It says charges plus q and minus q are placed at points A and B respectively. Distance between them is 2L. C is the midpoint. Work done in moving the charge q along the semicircle CRD. He mean to say that it is initially at C plus q, whereas at A there is plus small q, at B there is minus small q as it is said, is now moved from this C to D. Whatever the path, it is path independent. What is the work done in that? So there are two cases very much available. What we can say, case 1 is when plus q is at C. Let me draw a diagram for that quickly. This is our A, this is our C, B, D. It is given that at A there is plus q, at B there is minus q, distance between them is 2L, and this is also obviously L. Now at C there is a charge plus q, then it is moved to D. So when the charge is at C, between these charges there is electrostatic potential energy. We know the formula for electrostatic potential energy is 1 by 4 pi epsilon naught q1 q2 by r, where r is the separation between the charges. Now between this plus q, small q and plus minus q, there is a distance L. So between them there is a potential energy. So initial potential energy of the system is 1 by 4 pi epsilon naught is common for all of them. Between these two, plus q and plus capital Q by L. Now between these two, minus q and plus capital Q by L. Between this small q and small minus q, minus q and q by the distance between this and this is 2L. That is initial potential energy. That's the initial case. Now I have to move to case 2. Let us see what is that case 2 is. Case 2, when plus q is moved along CRD and kept at D. Finally it is kept at D. Let me draw the diagram for that also for you. Same diagram. This is A, this is C, this is B, this is D. At A there is plus q, at B there is minus q, that doesn't changes. But this q, capital Q is moved from C to D. Now the capital Q is here. Distances between them is L's. I can write new potential energy. 1 by 4 pi epsilon naught is common as per this formula. Now between plus q and minus q there is potential charge. Minus q and q by between distance between them is 2L. Between minus q and capital Q also there is a potential energy, that is minus q and q divided by L. Between the first and dot plus q and plus q capital also there is a potential energy, that is both are positive, q and q by distance between the first and last is L, L and L, 3L. That is the second potential energy of the system. What is the work done in this process is the question that is asked. So I can write work done in this case is difference between the potential energies. That work is stored in the format of change in potential energy. So I have to write U2 minus U1, that is final potential energy minus initial potential energy. In both this U1 and U2, 1 by 4 pi epsilon naught is common. So I can write that work done as 1 by 4 pi epsilon naught. Let me write this u2 terms first as positive as they are there. The first term is minus q and small q, minus q square by 2l. Second term is minus q and capital Q by L. Third term is plus q and capital Q by 3l. Minus u1, as I have to write u2 minus u1, I have to write a minus to all these things because 1 by 4 pi epsilon naught I already have written. This is plus, now I have to write it like a minus. Minus q into q by L. This is minus, now minus of minus becomes plus. Then that becomes plus q and q by L. This is also minus, now it becomes a plus q square by 2l. That's the answer that we want to calculate actually. But if you look at carefully, this is minus q square by 2l, this is plus q square by 2l. Both of them do cancel. Look at this. This is minus q by L, this is plus q by L. This also gets cancels. So what is remaining? That implies work done equal to 1 by 4 pi epsilon naught. Let me write the remaining terms. This is remaining and this is remaining. Q and q by 3l minus q and capital Q by L. That is 1 by 4 pi epsilon naught. Let's take LCM as 3l, q and q. Q as it is only L, 3 becomes a multiplication factor, minus 3q and q. So 1 by 4 pi epsilon naught plus q capital Q minus 3q capital Q, that is minus 2 capital Q by 3l. This 2 can be cancelled with this 4 as 2. So what is remaining is 1 by 2 pi epsilon naught minus q capital Q by 3l. So it becomes, what's my answer is minus small q capital Q by 2 into 3 is 6 pi epsilon naught and L. Look for this option. This is very much available here as the fourth option. So that's the answer for the problem. So it's a very simple problem. Only thing that you need to know is how do you write a formula for the potential energy. Once if you know that, you can write potential energy of the first case, you can write the potential energy of the second case, you can write the work done as the difference between potential energies and get the answer very easily, right? But you have to do carefully and you shall not mess up with positive signs and negative signs. That's it. Relook at the question if required, solve them on a paper and see whether you are getting it or not yourself. Never see my video and say that you got it, right? You will never get it. You have to do it on the paper, then only you will get it, right? Thank you for watching.